back. This is chapter 7, and in this chapter we'll be learning about HDFS, the Hadoop Distributed File System. We'll be starting this chapter by understanding what HDFS is and why it's needed. We'll see that it takes care of splitting our data files into blocks and storing these blocks on the nodes within our cluster. We'll be using the HDFS command line tool to put data into HDFS and get data out of HDFS, and we'll finish by updating our generic MapReduce template to automate deleting the previous output data out of HDFS before each job runs. So let's make a start. In the last chapter, we ran a Hadoop job in standalone mode. In this mode, Hadoop uses files on our computer just like any other application. We saw that our input data and our output file were normal files and folders that can be opened and viewed using a standard text editor. That's fine for development when we have small files and everything is running on a single computer, but when we get to production systems where there are lots of nodes and files of potentially hundreds of terabytes, Hadoop needs us to use a more sophisticated way of storing these files, and so it has its own file system. This is known as HDFS, or Hadoop Distributed File System. Suppose we have a 4 terabyte file that we're going to process using 5 slave nodes. Well, the Hadoop file system will take care of working out how to split up this file over those nodes. By default, large files will be split up into blocks of 128 megabytes, and each node will store some of those blocks. You might remember that earlier in the course I said that if a slave node were to fail, Hadoop can automatically carry on by assigning that node's work to one or more of the other nodes. Well, one of the ways that this can work is that Hadoop will not just place each block of data on one node only, but will replicate those blocks between the different nodes. This replication means that if one of the nodes fails, there's no data lost because all the data on that node can be found on the other nodes. The higher the level of replication, the more nodes can generally fail before our Hadoop job can't carry on. We can set the level of replication, that is how many nodes each block will exist on, in one of the configuration files. By default, the replication level is set to 1. That's fine in our setup because we only have one node. But if we wanted to set it to 2 or 3, we could add some code like this to the hdfs-site.xml file. Now, we're not going to edit this XML file because we only have one machine to develop and test on, so we don't need this replication, but we do, as developers, need to use HDFS to test our code. We want to run our code in pseudo-distributed mode for testing purposes, and HDFS is needed for that. Even while we're developing, we might well use data which is greater than 128 megabytes, and therefore our data would need to be split into 2 or more nodes in HDFS. In pseudo-distributed mode, with one node, that will work fine. It's just that all the blocks will live on a single machine. But Hadoop will still process each block separately, so our map task will run once for each of the blocks of input data. It's going to be important to test that our Hadoop jobs still work even when the data is split up like this. The way we work with HDFS is identical in both pseudo-distributed and distributed modes. We don't need to worry about how many nodes there are, and we don't have to specify which blocks of data get copied onto which node. Hadoop takes care of all of that for us. Included in Hadoop is a command called HDFS, which lets us interact with that file system split across all the nodes. This is a command line tool rather than a visual tool, but it allows us to completely forget about the distributed nature of how the data is stored and the fact that the data is split into 128 megabyte blocks. The HDFS tool presents the information as though it was in a single file system with what looks like standard files and folders. As developers with Hadoop, we need to know how to put data in, get data out of Hadoop, view the folder structures, and manipulate the folder structures, for example to create folders and add files. A list of the common commands that we'll use are on screen now. The put and get commands are used to put data into Hadoop and retrieve data from Hadoop, and all the others are very much like the standard Linux equivalent. For example, ls that we'd use in Linux to get a list of files in a directory does the same thing in HDFS. It's important to understand that when Hadoop is running in pseudo-distributed or distributed modes, it will only be able to access data that is in HDFS. So for us to be able to use Hadoop in one of these modes, we will need to put the data into HDFS first. Now there's a full list of commands we can use within the Hadoop documentation. We haven't yet seen the Hadoop documentation, so let me explain how this works. To find the documentation for Hadoop, we need to go to this website, hadoop.apache.org, and then click on the documentation link on the menu. Ideally, we would next click on the release that matches the one we're using. We're currently using 2.4.0, which isn't here right now because it's been replaced by 2.4.1, but that's not a problem. Click on the closest release that you have to the version you're using, so this may have moved on from 2.4.1 by the time you run the course, but just click on it anyway, and then in the URL up here, change it from the 2.4.1 to the current release that we're using, which is 2.4.0. As you can see, it's changed what's down there to 2.4.0. There actually isn't much difference between 2.4.0 and 2.4.1, so most of these pages will be pretty much identical, but that's an easy way to get to the documentation for the current release that we're using. If you're wanting to look at the documentation for the Hadoop libraries that we use in Java, for example, let's see what it says about the text data type that we've seen, we need to go to the API docs link. This is on the left-hand side, quite near the bottom here. Under Reference, we want to click on API Docs. This gives us a Java Docs style view of the Hadoop libraries. We could now scroll down this All Classes section to find the text data type. And we can see that, for example, in the constructor for the text type, there is a version which takes a string, and that's the one that we've been using. I'll leave you to read through the other methods and so on if you want to, but this is how to find the different parts of the Hadoop documentation that might be useful to you as a Hadoop developer. If we go back now to the Hadoop documentation main page, and I'm just removing everything in the URL here after the release number, and then on the left-hand side, click on File System Shell, that will give us the list of different commands that we can use with the HDFS application to manipulate the data files that are in HDFS. So we can see we've got our put and get methods here, there's ls, mkdir and so on. We'll be using a few of these commands on the course, but if you're interested you can look through these and understand what the other options available to you are. To use one of these HDFS commands, the syntax we need is HDFS, DFS, dash and then the command, and then any arguments. Here, HDFS is the name of the Hadoop application that lets us interact with the Hadoop file system. DFS means we're entering a file system command, and then we proceed with the command name itself, preceded with a dash, and finally any arguments that command requires. So for example, if we wanted to place a file into HDFS, we'd issue the following command: HDFS, DFS, dash put, and then the path to the file that we want to put in. If we wanted to get a list of all the files and folders in the current folder, we'd do HDFS, DFS, dash ls, and a variant on this, which I think is quite useful, is if we add in the arguments dash capital R, which means recursive, and a /, which means to start at the root, we'll get a list of every folder and every file within the HDFS system. So let's see some of these in action. Before we start, we'll need to put Hadoop into pseudo-distributed mode so that the service or daemon that runs the file system is running and ready to receive commands from the HDFS program. We'll do that by running the script that I provided that puts Hadoop into pseudo-distributed mode. And we'll look at this script in more detail in the next chapter, but I just want to point out it's this line here, start DFS, that actually starts the DFS service or daemon. So I've opened a new terminal window here. I'm just going to move into my documents folder, and I'll do an ls to remind myself what I've got here. So scripts is a subfolder, and that's where my start Hadoop sudo script lives. So I should be able to run the script by doing scripts /start Hadoop sudo. So follow along with me, get your version running in pseudo-distributed mode as well. I let that run off camera because it took a minute or two to start up. Obviously, depending on the speed of your machine, that might be quite quick or it might take a couple of minutes. So don't worry if that took longer than it has done on my machine on yours. If you need to pause the video just to catch up, then do so. You might notice we've got this warning coming up here about unable to load native Hadoop libraries for your platform. That is nothing to worry about. We're going to see that particular warning quite a lot, and you can just ignore it. The reason we get that warning is that we're using a 64-bit operating system, and the Hadoop libraries are actually compiled on a 32-bit operating system. It doesn't affect the functionality. Everything works fine. The way to actually get around this is to recompile Hadoop from the source code on a 64-bit system, and I don't think it's worth going to the effort of that just to get rid of this warning. So if you're getting that warning, just ignore it, don't worry. If you're not getting it, it might be because you're using a 32-bit system, in which case, of course, it's absolutely fine. So let's now try and use some of the HDFS commands to have a look at the file system within Hadoop. Let's first start by getting a list of all the files and folders in HDFS. Because we've not yet put anything into it, it should be pretty empty. So we'll do this by entering the command HDFS space DFS dash and our command, which is going to be ls, that's the list of files and folders in the current directory. We'll add in two arguments, which is a dash capital R, that means be recursive, go down all the files and subfolders, and a / to say start at the root directory. So that should list every file and folder in HDFS right now. We'll press enter. Okay, well, there's a temp directory and some things within temp that really we're not too worried about. We won't be looking at those in this course, so we'll ignore that. But down here at the bottom, there's a folder called user /node1. Node1 is my logon name. If you log on to your computer with a different name, then this should match your logon name. We created this folder earlier in the course when we first installed Hadoop. This user / and then your logon name is the default folder in HDFS. If we don't specify a folder for our commands, then this folder gets used by default. So if we try and place a file into Hadoop, it will get placed into this folder. Let's try that to see. I'm in locally my documents folder, and I believe my first speech file is in this folder. I'll do a local ls just to check. Yes, there's the file first-speech.txt, so let's put that into HDFS. We'll do that with HDFS, DFS, the command which is -put, and the name of the local file, which is first-speech.txt. I don't want to add any other commands because I'm not going to specify where within HDFS that file's going to go. We'll press enter. And nothing's come back particularly, but if we now reissue the command to get a full directory and file listing from HDFS, we'll see hopefully right at the bottom when it comes out, yes, here we go, my first-speech.txt file is there, and it's in that user / my logon name directory. The HDFS tool is giving us what looks like a simple file structure, but let's go and see what has been created in the background. One of the settings in our Hadoop configuration files tells Hadoop where on the hard drive to store its files, and assuming you didn't change it, that will be in var Hadoop. I'm in the root of my computer here, and if I go into the var folder, and then the folder called Hadoop, well, we can see we've got a folder now called HDFS. If I go into that, there's two folders called data node and name node, and if I go down the data node path into current, and then this folder here, and current again, and then finalized. Don't worry about how I've got to this point. I'm just going to show you that actually the file we've put into HDFS is sitting right here. If I open this in the text editor, there's our first speech from the As You Like It play. Now, I'm not suggesting you ever look at this file structure. All I want to point out is that Hadoop is creating this quite complex structure with lots of files and folders on your drive, and in a distributed system, this would exist over lots of different computers. But the HDFS command line tool is giving us a presentation of this structure which looks much easier to work with. So let's go back to that tool. We can put a whole folder into Hadoop in one go. We don't have to do it file by file. I've got that folder here called As You Like It, which contained a lot of files containing the whole text of that play. So let's put the whole of that folder in. It's the same command as we've just seen, HDFS, DFS, -put, and the name of the folder, which is As You Like It. Again, we'll do the list all the files and folders with HDFS. And we can see that, and I'll need to make the screen a bit bigger maybe to make it easier to see that. We've got here user, my logon name, a new folder within HDFS called As You Like It, and then each of the different files exist now within that folder. And we can retrieve files from HDFS using the get command. Let me delete the local copy of that first speech. So I'll do rm firstspeech.txt. We'll just do an ls to check it's gone. Yes, so it's not currently here. And to retrieve it, we'll do HDFS, DFS, -get, and the file, and this time I can either do /user/1/firstspeech, or because I know it's in my default directory, I can just do firstspeech.txt. I'm not going to give any other arguments because I want it just to go in the current directory, so I'll press enter. And now if I do a local ls, there's my firstspeech.txt. Note that getting data from Hadoop doesn't delete it from the Hadoop file system. Just in the same way as when we use the put command, it didn't remove the file locally to put it into Hadoop, it placed a copy into Hadoop. So get creates a copy locally of what's in HDFS. If we want to remove the file from Hadoop, we'll need to explicitly use the rm command to remove that file. I hope this seems quite straightforward. At the moment, there's no nice user interface for working with Hadoop's file system, but you can browse the file system through a web page. If you open your browser and go to localhost:50070, now that gives us a web page about our current Hadoop installation, and we'll be looking at this a little bit more later on in the course. But for now, if you click on Utilities and then browse the file system, we can see we've got our temp and user directories, and we can click on here to navigate into user, then my logon name, and then we've got either the file there or another directory in the list of files. I'm just going to go back a level. If I click on that firstspeech.txt and click on download, that will download the file to my computer. Now that might be quite a nice way to retrieve data from HDFS, but obviously you only want to do that if the file is very small. For much bigger files, it's probably best to stick to the command line. Perhaps the most common task that we'll do with HDFS, certainly while we're developing code, is using it to delete the previous output. You might remember when we ran the previous job in standalone mode, we would get an error if the output folder already existed, and exactly the same thing happens in HDFS. So if we're developing and we want to rerun our job multiple times as we iterate through our development process, each time we run it, we'll need to delete the existing code. Now, that would be quite a painful thing to have to do, to keep going into the command line and having to enter that command. So instead of that, we'll be revising our generic MapReduce template to include some additional code which does the job of deleting the previous output for us. So in the starting workspace for this folder, you'll find a file called generic MapReduce version 2. I'm just going to open this in a text editor to have a quick look at what the differences are. Well, I've got now an additional method here called delete previous output. This takes two parameters, the current Hadoop configuration and the path that we want to delete. And the code here is quite straightforward. We get a reference to the Hadoop file system called HDFS, and we try and issue the command called .delete on it. The comma true means make it a recursive delete, so delete the current folder and everything below it. I've got it within a try-catch block, and we ignore any exceptions because what's likely to throw an exception is if that file doesn't exist. So if we run our job and it doesn't work and the output folder never gets created, well, we don't want this to give us any kind of error. So this simple bit of code simply deletes any existing files and ignores any problems with that deletion. Within my main method down here, I've added in a single line, delete the previous output, to call that, passing across the conf that we've just created, the new configuration, and the out folder, the path that we got up here from our arguments. So I hope you'll agree that's a reasonably straightforward piece of code, but it does quite a nice job for us. This code works absolutely fine when we're running in standalone mode. The HDFS application will make this work on our standard file system if we're not in pseudo-distributed mode, so we can apply this code to all our templates from now on. The other HDFS point of note is that when a MapReduce job has been run on a cluster with multiple slave nodes, then the final output will consist of multiple files. One will be produced on each of the nodes. You might have noticed when we ran the job in standalone mode, the output was in a file called part R and then some zeros. The R here means it's the output of a reduce job as opposed to a map job, and the zeros is the node number. By default, the first node is numbered 0. If we have lots of nodes, the files will be called part R0, part R1, and so on. There won't be any duplication within these files, but when we retrieve them, we might want to manually bring the results together into a single file. HDFS gives us a way to combine these results into a single file at the point of the retrieval. The command is HDFS DFS, the command -get merge, our source folder and our local folder. Optionally, we can put the word addnl at the end, which stands for add new line, to ensure that a new line is entered in between each of the different parts. Unfortunately, we can't try that on this course because we're only running with one node, but this is something that might be useful for you if you're working in a multi-cluster setup. So we know now how to put data into Hadoop's HDFS system, how to get it out, and how to check what's there. So we're now ready to run some code using the pseudo-distributed mode. We'll do that in the next chapter, and at the same time we'll get a chance to practice using HDFS. Before then, I'd like to set you a small exercise. We're not yet quite ready to run our code in pseudo-distributed mode, so first switch back to standalone mode. There are two scripts you need to run to do this. You need to run the stop Hadoop script and then start Hadoop standalone. Then the exercise is to integrate the code that will delete the previous output to the two MapReduce jobs that we've already written. All we need to do is add the method in that can be found in the code file in the starting workspace for this chapter into both jobs and then call it from the main method. You can then recompile the jar file and run the code multiple times from the command line without deleting the input in between to check that this works. I haven't recorded a workthrough for this exercise as it's pretty straightforward, but there is some completed code in the final workspace for this chapter that you can refer to if you need it. So stop the video now, have a go at that exercise, and when you've done that, I'll see you in the next chapter where we'll run a job in pseudo-distributed mode.